Imagine the universe as a grand symphony, with every star, planet, and galaxy playing its unique part in an intricate cosmic melody. Just like a symphony is made up of individual notes played by different instruments, the universe is built from fundamental components that come together to create everything we see and experience. At a glance, these components are atoms, the basic building blocks of matter. However, what if these atoms are just the surface of a much deeper and more fascinating story? What if, just like discovering new musical instruments can change our understanding of a symphony, uncovering smaller, more fundamental parts could revolutionize our view of the universe? This is where our journey into string theory begins, inviting us to explore the unseen and unheard melodies of the cosmos.
For centuries, atoms were thought to be the smallest parts of matter. However, just like opening a watch reveals gears and springs inside, scientists have discovered even smaller particles within atoms, such as protons, neutrons, and electrons. These subatomic particles were once thought to be the ultimate building blocks of matter. Yet, the quest for understanding the universe at its most fundamental level did not stop there. String theory introduces a thrilling new perspective.
Imagine if all the particles mentioned above were not point-like dots, but rather tiny loops of vibrating strings. These strings are not made of any material we know, like cotton or nylon, but are fundamental constituents of reality itself, vibrating at specific frequencies, much like the strings of a violin or a guitar. This theory suggests that these strings are the fundamental building blocks, even smaller than atoms and the particles within them. By adopting this model, scientists hope to stitch together the currently disjointed theories of the very large, general relativity, and the very small, quantum mechanics, much like connecting different musical themes into a harmonious symphony.
String theory posits that what we perceive as different particles are actually just strings vibrating at different frequencies. Imagine plucking a guitar string and hearing different notes depending on how it vibrates. Similarly, a string in string theory might vibrate one way and appear as an electron, vibrate another way and appear as a quark, and so on. Each string's vibration pattern gives it unique properties, like mass and charge, which determine how it interacts with other strings.
This idea transforms our understanding of the universe's fabric. Instead of a universe built of point-like particles, imagine a dynamic tapestry of intertwined strings vibrating in various harmonious patterns. These vibrations underlie the fundamental forces of nature, like gravity and electromagnetism, binding the universe in a cosmic dance. Moreover, these tiny strings could be the key to solving some of physics' biggest puzzles. For instance, they might explain the nature of gravity and unify it with other fundamental forces, a quest that has eluded physicists for decades. This unification is akin to finding a universal musical scale that can harmonize different musical traditions into a single, all-encompassing melody.
String theory not only alters our conception of what the universe's basic elements are, but also suggests that there are more dimensions to reality than the three of space and one of time that we are familiar with. Imagine if, alongside your familiar spacious living room, there were a series of smaller, hidden rooms, accessible only under specific conditions. These extra dimensions are not usually perceivable, but they are integral to the theory. These additional dimensions might be tightly curled up so small that they are invisible to the naked eye, or even the most powerful microscopes. However, these hidden dimensions have profound implications. They could be the key to understanding how particles acquire their properties and how the forces of nature are distributed and interact across the universe. Think of these extra dimensions as secret corridors connecting different rooms in a house. They could allow for shortcuts or paths between seemingly unrelated phenomena in physics. This aspect of string theory not only fascinates scientists, but also sparks the imagination of all who ponder the mysteries of the cosmos.
A string theory is more than just a set of complex mathematical equations. It is a profound shift in how we perceive everything, from the tiny particles that make up matter to the vast cosmos. This theory could potentially be the thread that ties together all physical phenomena, providing a unified picture of the universe. Just as understanding the role of each instrument enhances our appreciation of a symphony, so too does exploring these fundamental strings deepen our appreciation of the universe. As we continue to explore these ideas, we should do so with a sense of wonder and curiosity. The universe is a vast, intricate tapestry, rich with mysteries waiting to be unraveled. Just like a child explores a hidden playroom with excitement, we too should delve into these new dimensions and possibilities with eagerness and an open mind. So the next time you look up at the stars or down at the intricate patterns of nature, remember the cosmic symphony being played on strings too small to see but immeasurably important. Let's keep listening and learning, always ready to be amazed at what the universe has to offer.